Hello and welcome to this webcast. Um, I believe most of you can hear well. If not, please feel free to use the chat window or the questions option to give a feedback to us. This is the second webcast which I'm doing in this chain of webcast happening on seeing the different specialized capabilities of our simulation products. Today, the discussion is on mechanisms, design of mechanisms, and using a particular module of SolidWorks, which is called as SolidWorks Motion. You have already seen this image, and yeah, to introduce myself, I am Kapil Gaitonde. I am based here in Singapore. I am the technical manager for Northeast Asia, and as well I am specializing in simulation products, flow products, these motion or kinematic analysis products, and finally plastic injection. So let's see what we are going to actually experience or try to design today. Okay, here it comes. So you have seen an image of this particular assembly, and this is the animation, or I would say more important, this is not simple animation, it is animation with all the kinematics involved in it. Now obviously to see it looks fabulous. It looks like, oh, what is simple mechanism. But imagine if you are a designer and you need to actually design all the intricacies involved in this particular setup. It could be as simple as giving the uh, distance of this particular wing. It could be the force required to push this thing down. Now, of course, in this case, I cannot, the spring that is present here is not highlighted. However, if at all you want, and you want to check out the exact stiffness of the spring that will be putting here, then of course we need to understand it using a kinematic simulation software like the one that we are seeing. Now this is definitely a simple mechanism, but give a thought at this one which is more complex. Let me go to the next slide. Here it is. So you can see this has many more things, and one of the basic things would be the motors that are going to come into picture here. uh, you want to design the motion of this entire setup such that it moves in a certain space at a certain speed, and it does the activities that it is supposed to do. As well, as I told you, these are not simple animations. These are, if you see the right side down here, you are seeing actually graphs which are actually telling the force variation, the torque variation, or even the torque required at these motors to rotate this entire setup. So this is another example of mechanisms, or in this case it is a robot thing on what might be required for simulation. And finally, this is another mechanism. Yeah, I can say it as a simple transporting mechanism. Looks pretty simple. um, I have shown this animation to a few, and many do not believe that this has been simulated in a kinematic simulation software. Many think it is just an animation. No, it is many more things than that. And rather today, I will use this same setup to show you how it has been created, or how SolidWorks Motion handles this kind of setup. So you can see the animation as it shows. It is just moving a particular log down the length of the plate, and finally it is going to slide down. Looks simple, a few mechanisms here and there, a particular motor which could be rotating, and let's get into more detail of this particular thing. So let me get you in the software. So here is how it looks. Here is how it looks. If I had to scroll through the SolidWorks CAD model, we have a few static components like the mount, the bearings which are present on the mount, right? These two simple bearings, and of course the sliding plate. So to simplify the understanding, these are the four parts which are absolutely static in this entire setup. That is, nothing is moving in these parts. there on the complexity comes, and of course, saying that even though they are static, one might want to decide the length or the breadth or the actual dimensions of these parts using this particular kind of software. Now let me get into more details. First of them is this particular transporting part. You can see it has a two holes. Maybe at those points there could be a bearing or a pin which is getting connected. We might want to decide the length or the gap between these parts. Similarly, at the top we have these multiple steps. We want to decide how these steps are, or the gap between these steps, what should be the height of these steps, all those details. There is as well a link down here. There is a bell crank, a few more links, right? All these are coming into picture. And imagine if I'm a designer and if I have to do this from scratch, I'm not aware of any of those things. Deciding the dimension of each one of these small entities is a very complex task. Definitely we'll start with a pen and paper. We'll draw some not random but some specific things, and then we can get into more detail of this entire setup, right? So this is the setup, and obviously I believe most of you may be comfortable with SolidWorks. You should be able to model and assemble these things. So when we assemble, we typically create certain mates in this entire assembly. Now here comes the first activity which is very important for SolidWorks motion, and that is deciding and modeling these mates. Now these mates are not created blindly. These are very relevant and active mates which will be used in motion. Uh, in the past, or to that fact even today, many of the softwares have a disconnect between the mates that are created in the assembly and the mates that will be used in the motion or the kinematic simulation module. Whereas in our case, as a designer, he creates an assembly which is actually being used in kinematic simulation. So he needs to take care of all the kinematic logics. Especially there is a big concept of something called as redundancy, which obviously I'll not discuss in complete detail. It might take another 2-3 hours to discuss only that concept. But we need to ensure all these mates are created, ensuring that there is no redundancy, or in one word, there is no multiple feedbacks to a particular part from multiple mates. So as minimum mates need to be created, the important mates need to be created, especially the place where we want to measure the forces, torques, etc. So on doing that, once it is all ready, typically we activate in SolidWorks add-ins a module by name SolidWorks Motion, and at the bottom you will see this particular motion module being active. So this is how it looks. Most important, as I told you, if the mates are created well, they are all present down here. So all the mates come into motion, they're active and working in SolidWorks motion. So these need not be created again. So obviously now what remains is the motor which is going to rotate this particular mechanism. So you can see here there is a part down here, the circular part. Uh, we can assume there is a motor sitting down here, and that motor and that motor rotates this particular circular part. We are using a speed of 100 rpm, which is quite huge, and with certain references the motor is going to act in a anti-clockwise direction down here. Okay. Second, okay, from a design perspective, again I need to decide what should be the capacity of this motor, how much torque it is supposed to deliver, and all those finer details. Second is the contacts. So in motion as well, we have contacts wherein we are defining. Now in this case there is a small metallic component at the top here. We are saying it has a kind of contact by which it will not penetrate between the part adjoining it, and we can tell it the type of contact, we can specify the friction and other details of that contact. Finally, oh yeah, sorry, we have one more contact. You can see this one again between the transporter or the actual thing which is moving the part. We need to create that as well. And finally, the component would be the gravity. Obviously, we need to specify how this setup is present in the atmosphere and how the gravitational forces are going to act. So this is one part of the simulation, or these are the extra things which you need to do in motion. That's it. Assuming you are done the estimates properly in SolidWorks CAD part of it, this is it. On doing that, let me play the results down here directly. So this is how it looks. Now in this case, you are actually seeing it in the software. It is not an animation. You can see it. Okay, so it is as simple as that. But obviously the question would be how it looks when I solve it. So you can see that while solving it is quite fast. It is rotating at 100 RPM, as well as it is not taking, or it is fast as well because of a good machine that I'm using here. But typically, even though many calculations are involved, you can observe it is quite fast. But yeah, these was the creations, and these were the details. But the most important aspect, or the most relevant thing over here, would be seeing the values, which are equally important. So I can actually create a graph of the motor torque. You can see here the torque is being acting at a location where it is present, uh, or at the location where the motor has been created. I can select it as per graphs. Typically the option comes down here. We select the different kind of forces. It could be forces. I can select the motor torque, etc. So as I told you, this is not an animation software wherein we are actually just seeing the animations, but I can know the torque that is going to act on this particular object. So one part would be that, as well as you can find out the forces acting in different limbs. This could be further taken to stress analysis, and you can do the stress analysis to visualize and understand the forces which are coming in this setup. So this is how the simulation works, or the motion setup is created. Yeah, one of the important things which I would like to highlight here would be something called as degrees of freedom. Now you can observe here, of course, it is showing almost zero redundant constraints. But uh, if we see if we see the setup or the assembly, we have around 8 moving parts, that is creating around each part having 6 degrees of freedom. We are seeing around 48 degrees of freedom. Thereon we create joints which are going to restrict or constrain or guide how these degrees of freedom are going to move. So using that, you can see it will remove certain degrees of freedom. And finally we need to ensure, now this is what I mentioned when doing it in the assembly. When we create the mates, we need to ensure that all these different joints or mates are created appropriately, such that the final balance is almost zero, or there are no redundant constraints in the setup. Okay, so this needs to be done, and this is the biggest challenge, which will be, or the most intricate thing that you might do in motion. Remaining all, you can see it is quite simple. Assembly, we are quite comfortable. The motion, the front end is quite easy. You just follow through certain things. We are using all design words like motors and springs, stiffeners, dampers, etc. So those can be used directly. And finally contacts. So this is how it works. This is how we create the setup, and how this is how you can simulate such a mechanism. Obviously questions would be, or the problems or the changes that will come into picture. Typically you do such a setup, you'll observe that the part will not move the way you want it to move. So obviously you can change the dimensional details. You can design the bearing dimensions based on the forces that are coming at that particular location. Typically for FEA, one of the important challenges will be to find the forces at those different locations. So one can use a kinematic simulation software like Motion to find the forces, and thereon we can do finite element analysis. As well, the intricate links which you can see here, these can be designed in detail. So this is how it works, or this is how it is created in SolidWorks. And yeah, if I had to show you one more, if I had to show you this one in a standard view, let me check it. because that gives a better view. Let me try to play it in this way. So you can see here, this will show you the exact working of the mechanism. What could be happening, a simple motor is rotating it, and further the action happens at the top. Let me stop this, get back into the presentation. And so here it is. One is what you saw now, more of kinematic simulation. But saying that, I would also like to highlight there is something called as event based motion in this, or it is an extended module of motion, wherein you can actually create motors which respond to certain events. So as you can see here, the particular red box which is not having a hole, and there is a yellow box which is actually having a hole. So we can say we can have a sensor down there which will sense whether the part is having a hole or it is not having a hole, and we can do the sorting. So typically in process oriented industry or the manufacturing processes, if they have to be simulated, visualized, and then further optimized, then one can use a module like this, which is called as event based motion, to trigger, understand, and know the total time taken, improve the logistics, as well as improve the total time taken to manufacture a particular part. So this is one interesting extension of motion, which is called as event based motion. And if you see it in a more complex animation, is this one, wherein you can see multiple things happening. So it's again a complete manufacturing process. So you can see many things happening here, and obviously to plan such an entire assembly or a process is quite complex, and one can use a module like motion to understand and simulate such an entire setup. Okay, and finally something more, nothing much mechanical here, but looks nice. And just to give an idea, you can simulate these kind of things as well in SolidWorks motion.